And so before we jump right into the proof of this, let's have a look at a number of the form of what we were looking at last time, which is a plus square root of q, where a and q are rational numbers. Basically, let's look at a very simple example, which is 1 plus the square root of 2. So you can have a go yourself trying to find a polynomial that has this as the root. So I'm going to have a look at a very systematic approach for approaching this. So just have a go yourself, and then let's have a look at what happens. So, okay, now I'm gonna just go ahead and do it. I don't know how to pause the video. That'd be pretty awkward. So we'll square this like that. Okay, so why are we squaring it? We will not think too much about that right now, but we're going to square it, and then we get 1. We multiply these two, and then we get 2 square root of 2, this bit, and then we get 2. If you don't see how this worked, then consider revising how to square numbers. Then we add 1 and 2 and get 3, like that. And oh dear. Anyway, and this just carried down. And what we're going to do is we want to do something a bit clever right now. We're going to notice that this is equal to 1 plus 2 plus 2 root 2. I hope you followed along until now. So 1 plus, so basically we're factoring out the 2. We're using the distributive property, so you know that the rationals, actually the complex numbers, in fact, because we're just assuming this is complex or whatever, but in fact it's real numbers, is fine. That you can just use a distributive property, and basically everything in algebra just works perfectly fine. And even if we didn't know what this 2 was, there are some clever ways of just constructing this using using the polynomial that we talked about before, using isomorphism, some isomorphism theorems. But look, so what we have is that essentially this is it. Right, so if we call this alpha, like we did before, we have that alpha squared is equal to 1 plus 2 alpha, and if we rearrange that, we have alpha squared minus 2 alpha minus 1 is equal to 0. So basically with p, in this case is x squared minus 2x minus 1. So we have found a polynomial that has alpha as its root, alpha being 1 plus root 2, and so 1 plus root 2 is algebraic. So we see that it's not exactly easy to do this, so we need some kind of tricks or something to get to this. So the general approach for solving this problem, we probably wouldn't want to use this method. So in the next video, I'm going to introduce another method that we can use to for this problem, this method's fine. So I'll actually prove that for numbers of this type, this method works. But then afterwards, I'm going to just do this whole thing again with another better method, which you can use to show that the sum of any 2 algebraic numbers is going to be algebraic, and same with the product. So yeah, so I'll see you in the next video.